Okay, guys, let me introduce myself. Myself, Prabhanshu Saxena, working as a software engineer. My role is solution architect. I have over 12 years of experience in IT industry, and my current responsibilities include solution designing, project estimation, and project plannings. I welcome you all in today's session where we're going to discuss about software estimation methods, or more appropriately, software estimation techniques. Good morning, everyone, whoever is joined from Indian time zone, and good afternoon, good evening to the people who joined in different time zones. Let's have a quick look at today's agenda, and then I will start the discussion on the topic. Today's discussion will have a bit of overview on the estimation. Then we will talk about why we need to estimate. As it's a software estimation techniques, I will be more focused on the software part, and probably I'll be using some terminologies. You can note down your questions, and at the end when we'll have a Q&A session, we will discuss about your queries. So once we understand why an estimation is required, we will talk about some of the popular techniques in software estimations, and then we will pick a couple of them to discuss in today's session in a little deep, in a little depth of that. I'm not going to discuss in detail all these software estimations because it's quite a wide area. Okay, I see something. No, am I not audible or the presentation is not visible, guys? Can you hear me? Say yes if you can. Okay, great. Great, thank you. And I hope the presentation is also visible. There are no issues with the presentation as well, right? Great. Okay, so coming back to the point, guys, we'll talk about some of the software estimation techniques. We'll have an overview and little of details on those estimates. The next topic, how to choose the right technique. We will cover it along with the techniques that we're going to discuss today. We'll spend some time on Q&A, and then we'll close the session for today. And we'll see, like, if you like the session, if you want to go in deep of these software techniques, we will arrange another sessions specific to those techniques that you want to interested in. Okay, so let's move to the overview. First of all, estimation. What is estimation? Basically, we define it as an activity which we use to come close to the actual investment where we're going to make to build, to construct, or to invest in any product. In simple terms, it's a process of finding an estimate or approximation, which is a value that can be used for some purpose. So when exactly estimation make more sense? It makes more sense when we do not have accurate or adequate input data, when the details are uncertain, they are unstable. In that case, we cannot arrive on a certain situation by when a particular time, by when a certain amount of money, by when a particular schedule is going to complete. We go for estimations. Okay. Moving to the next slide, why? So we understood what is estimation, when to use it. Now, why to use it? So it's a simple concept, guys. Estimations determine how much money, effort, resources, and time it will take to build a specific system or product. What does it mean? It means that build any system, be it software, be it any other activity we do, we need to know whether it is worth to invest in that product. Is it worth to spend that much of time in that activity? Is it worth to engage so many resources into that project? If not, then probably with the estimation itself, we drop the idea to go with that activity, right? Now, coming to the software industry. So the estimations for different hierarchies are different. For example, if you talk about the developer, I see voices breaking. Comment, guys. Is it fine or is it still breaking? Okay, great. Thank you. So yeah. So as I was saying, like in software world, the estimation means differently for different people, different roles. So say for example, for a developer, an estimation of time is important to estimate how much time it requires to complete his tasks so that he can align or arrange his different tasks to complete his responsibility. For a module lead or a project lead, the total effort estimation is important for him to see like how many resources would be required to complete that project or a module. What are all the other resources like infrastructure, hardware? All those things will be required to achieve the goal. Okay, I still see a comment, not able to hear you. I'm not sure if it's a problem with all or for some people. Okay, fine. Might be a problem with your network, guys. I think for others, it's fine. Okay. So coming to the management part now, the most critical, and who are the most curious and curious to know the estimates, because the management deals with the cost. They need to see what budget they should allocate, what budget they have, and how much they can accommodate to complete the project, right? So as I said, like estimation means differently for different people, different rules. What we're gonna do today, we are not gonna talk about the cost because it is basically dependent on the organization, how they define their costing model. But we are certainly gonna talk about the effort estimation and the time estimation. What are the basic steps, 4 basic steps that we usually do in all the techniques? So first of all, to understand what is the size of the development product. When we say size, it doesn't mean how many hours required, how many days required. Size is a unit which basically defines the complexity of a particular functionality. Okay. And based on the size and prior experience, we derive our efforts. So the next point is estimate the efforts in person months and person hours. There are 2 ways, guys, here. One, we define the size, then we calculate efforts. Other one, where we are sure about the activity, we have enough experience, expertise, we directly go for effort-based estimations. Once we have efforts with us, we work on the schedule. Okay. So when we say that a particular activity needs, say for example, 60% days to complete, that means if I engage 2 people, the activity should be completed in 2 months of time, 2 calendar months of time. So that is what is called schedule. When it comes to schedule, basically project managers decide what level of roles, what kind of people, what kind of expertise would be required in the entire development cycle and in different phases. Okay. And this schedule defines the timeline of your final project delivery. Once we have the schedule, once we have the efforts, when we know what sort of skill set would be required, the project managers calculate cost out of it. And the cost and the time then discussed with the client for the engagement. I hope whatever we discussed so far, you guys are with me. Okay, great. Let's move to the next slide, which lists out some of the popular estimation techniques. They are not all. I mean, there are a lot of test techniques. There are organizational level techniques that people are using for estimation. These are some of them which are most frequently used in organizations. Function point. Let me give you a bit of brief all of them, and then we will pick some of them to go into deep dive. So first thing is function point. What is function point? In this particular technique, we identify the functionality in our product and we estimate the size of these functionalities in terms of complexity. Okay, that's why we call it as function point. The next one is the story point or use case. So it's similar. I mean, they are quite similar to function point. The only difference is we talk about the user stories here. They are more appropriate when you go for agile kind of methodology in software development. So in agile, the requirements are defined in form of user stories or use cases. And when we estimate the complexities of story points or use cases. Okay. The next one is project evaluation and review technique. PERT. This particular technique talks about the average estimates of the best case and the worst case. What does it mean? Basically, what we do is, for any particular task, we have a meeting with the team and we consider different scenarios, like the most optimistic scenario, where we are very clear about the requirement and we have the best skill set to deliver that. In that case, what should be the delivery timing? Second option is, when we have an average team to deliver that task, what should be the timing? And the last, when we have a new team on ground, doesn't have right skill set or enough skill set to deliver that. There are a lot of gray areas in requirements. Then what should be the timings to deliver that? And then we go for the average of it. Okay. Then it comes to 3-point, which is quite similar to PERT, but these two techniques differ in terms of the formulas that we are using to arrive on estimate. Okay. So if you use one type of formula, it lands you into PERT estimation technology. If you use a different formula, you ideally land into 3-point estimation technology, estimation technique. The next part is work breakdown structure. Work breakdown structure, at its name itself suggests that we go for granular details of the work that we are doing. And all those granular tasks are then estimated. And by rolling up the tasks from bottom to top, it defines the total estimate required to deliver a product or a project. The next is wideband Delphi. This is quite interesting, but quite lengthy technique. Basically, I'll give you a very quick overview of what it does, basically what we do in wideband Delphi. In this particular technique, we have an estimation meeting. We give an estimation sheet to all the participants of the meeting. these people, these participants, come up with their own estimates. And then the coordinator consolidates those estimates and prepare a chart where we see what is the difference, what is the deviation in these estimates that are given by different people. Once we have that chart ready, the participants discuss the points basis on which they had given the estimates. This round of discussion clarifies certain approaches that different people had taken, go back and revise their estimate. Once they have their estimates again, this meeting goes again and see what is the difference. And this activity goes on with all the participants arrive on an agreement that yes, this is the optimum estimate you can have for that activity. Okay, I still see comments. Voice is suddenly breaking. Okay, guys, there's a little weather problem here, and that's the reason network is breaking in between. If it's not clear, and if you want to go back to any point, just type it here. I will explain that again. Okay. Am I sounding good now, or is it is still breaking? Is it fine now? Okay, great. Great. So yeah, just tell me the point that you could not understand. I'll go back to that and I'll explain it again. Nice. So we discussed about wideband Delphi. The last one is analogous, which, okay, PERT. I'll go back, PERT and 3-point. Okay, I'll go back to that. Anyhow, I mean, that is one of them is part of our today's discussion. We will cover in upcoming slides. Don't worry about that. Okay. Analogous estimation technique basically depends on the past experience. What does it mean? It means that if we are developing any functionality on which our organization or teams have worked in past, we take that experience, we see like what is the difference in current requirement and the past requirement. And according to that, we arrive on the estimates. Okay. So these are some popular estimation techniques. And as I said, like we will pick some of them today to discuss in more detail. So today's scope is divided basically into two parts. As I said, like there are two ways of estimating a project. It might be size-based, it might be effort-based. Okay. So in today's session, we are picking two estimation techniques from size-based techniques, two estimations from effort-based technique. Okay. So from size-based side, we will pick function point, which we will look into more detail. Then we'll pick into story point. And as I said, both are quite similar. The difference is in the formulas, actually. And from effort base, we will pick 3-point and the WBS, right? So let's start with the function point estimation. So as previously discussed, function point estimation is basically an estimation technique of sizing the application. Okay, we will also see how we will derive the efforts out of size, right? So let's understand. how these function points are derived. In function point world, we divide the entities into three categories. One, the system, which we are going to estimate, which you can see in the middle, with this application being measured. Okay. The users who are actually using those systems, who are giving certain data, just like data entry operator. Okay. Where we go, we fill a form, and the details which we are filling in the form are going into some system. So these users are external users which are feeding information into our system, as well as they are seeking some information from our system. These users are physical human beings, basically, who operate day-to-day activities using our software. Third activity or third entity in this world is the other applications. Now, these applications might be a web service. It might be a different system which is dependent on the data that we are passing to them. This might be a system from which we are getting certain data for our internal purpose. Okay. All these kind of transactions that are happening with users or with other applications are called EIF, EQ, EI, EO, ILF, and EIF, basically. Now, what is these terms? Quite jargons. Right. We will discuss that. We'll discuss that in upcoming slides. Right now, from this diagram, you should understand EIF, which is external interface file. What does it mean? It means that the data is coming from other application to my system. They are not physical users. They are not human beings. They are just the applications like batch service. This might be some web service which is providing data from other system. EQ is external inquiry. External inquiry, that means they need certain detail from us in the original or raw format. That means if a data is stored in 4 columns in my table, I will provide that data as is to the other application or the user without any modification in that. It's kind of report. You can treat it like a report. Okay. A report, plain report without any manipulations. EI, which is external input. External input means you can imagine like a registration form, right? When you go to any website and you register yourself, it demands certain information about you. You feed that into the form and click on enter, and that information goes and sits into our system in our database. So that is called external input. This input might be coming from users, human beings. This input might be coming from the other applications. Okay. The next one is EO, which is called external output. Again, external output is similar to external inquiry, but the only difference is external output contains certain calculation. Now, let me give you an example. So when we say that I need a report of the employees who are going to get the bonus in this month and what would be the bonus amount. Okay, so if I stop my requirement saying that who are the employees basically gonna get a bonus on this month, I'm ideally not going to perform any operation in the database. I'm not going to do any calculation there. I just go to my database and say that, boss, tell me who are the employees gonna get bonus this month. Get that information as is and provide to my user. That is external inquiry. But if I extend my requirement saying that calculate the bonus now. And the bonus should be 5% or 10% of your base salary. Give me that. In this case, I'll go to my system. I'll check what is the basic salary of an employee, multiply with the 5% of it, and show the result as a bonus amount. What exactly I did? I actually involved some calculation in my report. And as soon as I do that, my output, my report becomes external output. Okay. These 5 terms that we are using, external input, external output, external inquiry, internal logical file, external interface file. So we did not talk about what is internal logical file. You can consider, or you can take it as a table in your database. One internal logical file is like a table in our database, which is containing some information, which is holding some data related to the application. Okay. I hope you are clear with the terms that we are using in function point. With the next slide, we'll broadly talk about the complexity that we're going to derive from these transactions. Okay. Let's move to the next slide now. Okay. I hope you see certain matrices, which are basically talking about different terms, just like external input, internal logical files, and then there are weightages given to it. Okay. So there are 2 parts of it. You see, take an example of internal logical file. We have DETs, which are basically data element type. In simple word, they are the columns in your table. RETs are record element type. In simple words, you can treat them as rows in your table. So if any operation, any requirement needs a report in which the number of rows are more than 6 and the number of columns are between 1 to 19 or 20 to 50 or 51 plus, we define the complexity of the requirement. So take an example. I am fetching a report which is ideally resulting 1 row update, and 1 row is having around 15 columns in it. Then the complexity of this operation is low. So L denotes low, A denotes average, and H denotes high. Right? Once I did identify the complexity, I will give it a weightage. So point is nothing but a weightage to that complexity. So if my requirement falls under low complexity, I will give a weightage of 7. If it falls under average, I'll give a weightage of 10. If it is in high, I will give a weightage of 15. When the operation type is of internal logical file. Similarly, if it is external interface file, means we are getting certain data from outer system, and based on the RETs and DETs, if my complexity falls under low, average, and high, you see the different weightage here from the internal logical file. The weightage is 5, 7, and 10. Okay. Same way, we go for external input, external output, external inquiries. So each type of transaction, so when I say transaction, I am talking about these operations: internal logical file, external interface file, external output, external input, external inquiry, 5 type of transaction. So based on the transaction, I define the complexity, and based on the complexity, I define the weightage of it. Now, the question might be, no voice. Am I not audible, guys? Hello? Am I audible now? Okay, cool. Okay, so far we discussed that in function point world, we define the type of transaction, and based on the transaction, we get the complexity of it, and then we give a weightage of it. The obvious question would be, how did we get this matrix? From where this weightage is coming? Why are you saying that the low complexity will fall under 1 RET and 1 to 19 columns or DGs? The answer of that question is, there is an institution called IFPUG, International Function Point User Group, which manages the function point rules, their standards, the protocols, and these matrices are defined by this institute. So you can Google it out. You can just Google IFPUG, International Function Point User Group, and you will see a lot of details in that website. Okay, and that's the reason the function point estimation technique, is considered the most reliable technique, because it is estimated based on the scientific data, scientific matrices, which are derived after a lot of investigations and researches. Before I move to the next slide, I want to repeat this slide again for a better understanding. In function point, we identify the type of transaction. We have 5 types of transactions here. Type of transaction. We identify the complexity of that transaction among low, average, and high. And we give a weightage to each type of complexity. Now, how we use it in a broader term, okay? Let's look at the next slide. This is a simple template that we had designed to support the function point estimation. The left side, you see there are different function names. Okay, you see waiting function, maintain function groups, maintain holiday calendar. These are functionalities. And as part of this functionality, exactly what type of transaction we are going to do. So you see, for maintain function groups, it's internal logical file. That means we are ideally designing the database. How many tables and how many columns? We are planning to do that. Okay. And once we put that information, we get the complexity and we get the functional size of that functional requirement. This functional size is called function points. On the right side, it's not very visible at the moment, but let me give you a brief of it, what it is. It's called value added factor. Let me type that. Value added factor, which is known as VAF. What are value added factors? When we are finding out the function points using complexity and weightages, they are ideally tell us the size right from requirement gathering till deployment. But they do not consider the technical hitches or challenges we might face during the development or deployment process. They do not consider the organization level processes. They do not consider the architectural level complexities. And if you do not consider these aspects, your estimate may, may go wrong horribly. So to support these activities, these challenges, value-added factors are incorporated in this technique. And there are different categories in value-added factor, which we call the difficulty levels or degree of influence. Degree of influence. So when we say degree of influence, what does it mean? It means that in a normal client server architecture, an operation might be easy. So it's a low degree of influence. But in entire architecture, the same operation may take little more time because you have to manage different layers. You may have to manage different protocols, which are more aligned with the architecture. In this case, you need a little more time to develop it. That means the degree of influence is increased. So like that, there are 14 or 15 categories defined in value-added factors. And based on the complexity of those categories, we again give some weightages. Okay, so let me explain how it works. So these numbers that you see on the screen right now, total unadjusted function point, 54. This 54 is coming from the left-hand side table, which is not considering the complexities or the degree of influence. And that's why we are calling it as unadjusted function point. The second section, you'll see like total non-functional assessment factor, which is value-added factors. That means your degree of influence, 1.8, that is derived from the complexity factors that we are giving here. Okay. Why are we getting 1.8? Because there is a formula to get this number. So the formula here is, I'll type that into chat so that everyone can get that. The formula is 0.65 plus TDI multiplied by 0.01. Okay. TDI is nothing but the total degree of influence. That means the total weightage of this section is called TDI, total degree of influence. And based on this formula, we get the assessment factor. And using these two, unadjusted function point and the assessment factor, we arrive on the final number of function points. In this case, it is 152. These are all dummy data, guys, so don't take it very seriously, okay? So 152. So when I say 152, that means this is the size of the requirement that I had. So we arrived on the sizing. The next question is, okay, I know the size, but how much time is required to deliver it? So I need to figure out the efforts, the next section, the next step. To figure out the effort out of my size, I need to know what is my productivity figure or what is the productivity figure of my organization. This comes from the past projects. So every organization maintains it basically. So for example, if you look at this table, it says that if my function point is lies between 50 and 350, it's a small requirement. And we can deliver 20 function points in a month. But that 20 is specific to .NET platform. That means if I'm using C# or VB.NET. If it is Java, this figure may change. Okay. So the important part over here to notice is when I'm converting my function points to my efforts, these efforts derivation depends on the technology that I'm going to use. It depends on the programming language that I'm going to use to develop the software. Here I have taken example of .NET. If you go to Python, if you go to Java, if you go to other language, this number will vary based on the programming language. So how calculation happens? So my total function points are 152 that we have seen in last step. Efforts in month. So what we are saying that we can deliver 20 function points in a month. That means 152 divided by 20. That means I will need 7.6 person month. Person months means one person can deliver this requirement into 7.6 months. And 7.6 months means if I convert that into days, so in IT industry, we usually take 21 productive days in a month. So if I multiply it with 21, I see 160 person days. That means delivering 152 function points, one person will take 160 person days, 160 working days. If you remember the third part, schedule, which we discussed in the second or third slide, next step is finding out the schedule. Schedule depends what is the timeline of my delivery. So my timeline of the delivery is 3 months. That means 160 working days work I want to deliver in 3 months. Then how many people required? So 7.6 months divided by 3 months. That means I will need 3 people to deliver 152 function points in a period of 3 months. So in function point estimation technique, we saw what are the matrices which are used to identify the complexity and weightage of a transaction. We derive the function points. Then we derive the duration, efforts required to deliver that. Then based on the project timeline, we identify how many people will be required to deliver this particular requirement. Okay, so guys, function point estimation technique, as I said, is a very, very effective, accurate, if you correctly use it, I would say. Okay, there's a lot of understanding required to understand these 5 terms: EI, EO, EQ, ILF, EF, and all that. I have just given you an overview. You can go to Google and figure out more details on it. Okay, but as a whole, this is the way we use function point estimations for approaching the appropriate estimation for a requirement. Okay. So with that, let's move to the next estimation technique, which is story point or use case estimation. As I said, use case or story point estimation is similar to function point. Only difference is if you are working in an agile model. I hope you guys are aware of agile model. So in software world, agile model totally depends on the user stories. We create product backlogs, sprint backlogs. We estimate the efforts based on the complexity and weightages on the user story. Okay. So instead of functionalities that we had seen in function point, if we have a user story as a requirement coming from client, we directly estimate or give a complexity to that user story. So if you look at the first table here, it says that any user story which needs less than or equal to 3 transactions. So when we say transaction means either you can updating the system by providing some information, or you are retrieving some information from the system, right? So these activities are called transactions. So any requirement which needs less than equals to 3 transactions, we give a weightage of 5. If the transactions are between 4 to 7, the complexity level becomes average and the use case weight becomes 10. If transactions are greater than 7, it is considered as complex requirement and the weightage is 15. Now, let me make this point clear. In function point, the matrices that we had seen are scientifically defined. But in this case of story point or use case estimation, that gives you an approach. But defining numbers of transactions or the weightage is actually in your hand. So based on the nature of requirement, you ideally can go and define your own number of transactions. You can give your complexity and you can give your weightage. Ultimately, our objective is to define the size of my requirement or, okay, okay, there is a comment for more transactions, estimation of use case is same. Yeah. So definitely, see, as I said, if it is more complex, so yeah, see, it's always relative, guys. It's always relative. As I said, the number of transactions are in your hand. You define it based on the size of your product, based on the complexity of the product or the requirement that you are dealing with. It's not limited to 3 or 7 or more than 7. It can be anything. I can have 5 transactions into simple category. I can have 10 transactions in the category of complex. If it's very complex, you can give the weightage. Okay, it's more over the understanding and agreement among your team members. If you look at the second table here, okay, what we do is, say for example, in one release, we got around 30 user stories, right? So the team sits there, they say, okay, out of 30, these 5 are simple user stories, okay? These 5 are simple user stories. So NSUC is nothing but number of simple use cases or user stories. Then 10 are average and 15 are complex. So we have not gone to any matrix here to see like what type of transaction it is. It is EIF, LIF, in external input, external output, what type of transaction. No, we are not doing that. What are we doing is we are going through the user story. Looking at the nature of it, we give it a weightage. Okay. So in 30 user stories, 5 user stories, we have given the weightage as 5. In some user stories, we have given the weightage as 10. And some user stories, we have given weightage as 15. Then we multiply the number of user stories which we have given weightage as 5 with the weightage we have defined in our complexity matrix. So say for example, for simple complexity, if I give a weightage as 6, ideally in this table, I will multiply the number of simple user stories or use cases with 6. Similarly, for average, I will multiply with 10 because 10 is the weightage I had given for average user stories. Same for complex. The number of user stories which are falling under complex category will multiply it with the weightage I have given for complex category. So in this case, it is 15. So I'll multiply it with 15. And then I'll get the total number of unadjusted weightage of my user story. Now, it's falling or it's actually aligning with the function point again. From here onwards, we got the weightage of user stories. If you go to the next slide, you see we have similar table here, which is defining the complexity. It might be distributed system, response time throughput, end user efficiency, portable, not portable, concurrent, not concurrent, and all kind of things. We are categorizing the complexity and giving different weightages to it. And the final formula is still same. From the weightage from previous sheet, which is unadjusted user storage weightage, we multiply it with the technical complexity factor. And that gives me total number of use case points or story points. At this moment, I got the size of my requirements in terms of story points or use case points. Deriving efforts out of this, again, goes back with the productivity figure of your organization. So whatever calculation I had shown you in slide number 10, the same calculation will go with the story point, depending on the productivity figure. Okay. So with this slide, we covered 2 estimation techniques which are size-based. Now, let's look at the estimation technique which is effort-based. So we are picking the very, very simple estimation technique, which is 3-point estimation. Okay. And as I said earlier, 3-point estimation and burst estimation is almost same. It's only the formula which differ them basically. So what is 3-point estimation ideally? In 3-point estimation, we actually focus on 3 approaches. Okay. 3 approaches are: what is the best case, most optimistic, what is the average case, like most likely, yes, that can be achieved, and what is the pessimist, the worst case scenario. And then we use this formula to get the efforts. So say, for example, let me go to the whiteboard. I have a requirement of designing login screen UI. Okay, so this is the task my team is working on. And I want to estimate how much time a login screen UI will take to design. And I'll ask my team, okay, team, say for example, if you have the best designers with you, you know the details of the requirement to design this login screen. How much time do you think you need? My team says, boss, we need 5 days to complete. So when I say, oh, that means this is the optimistic scenario, idealistic. I know my requirement. I have my minute details of the requirement, and I have best team with me, have a perfect skill set to deliver that. Okay, fine. But there are uncertainties. Maybe I may not get the right skill set or that effective skill set in my team. In that case, what would be the effort? In that case, my team says, okay, boss, if we are not very clear about the requirement, and if I don't get the people that I am demanding to deliver this, most likely I would need 7 PDs to deliver that. PD is percentage. Okay. So it's a fine. Now let's go for the worst scenario. My requirements might be clear, but you have new joinees. Say, for example, when you're developing it, somebody resigns. Quite common, right? In IT industry. Somebody resigns and a new guy joins your team. And that person doesn't know the background of this requirement. He doesn't know what was discussed, what is the architecture. He needs a lot of information from you. In that case, what would be your approach for the estimate? How much time would you need? And my lead says, boss, okay, in that case, I may need 10 PD, where I will guide the person. I will help them with the additional requirement. We also need time for him to ramp up. And then, yeah, we can deliver into 10 days. Good enough. As a lead, as a project lead, or as a manager, this figure gives me an idea that minimum 5 and maximum 7 PDs, 10 PDs would be required for the delivery of this method. Then, okay, what would be the ideal case or the estimate that I can present to client on an average to freeze my estimates, right? In that case, what I will do, okay, I need to rub it a bit. I'll go back to my presentation. Little more time. I think I had drawn last. Okay, great. Thank you. So in that case, I'll go back and I'll say, boss, let's use the formula that I have to help me. My formula is optimistic efforts plus most likely efforts plus pessimistic efforts divided by 3. That is, ideally, I'm averaging it out. In my case, my optimistic effort was 5, most likely 7, and pessimist was 10. Okay, divided by 3, and that gives me around 7 PD of estimate. That means I will need, on an average, 7 PD effort to deliver that particular functionality. Okay, so that's how 3-point estimation works out. 3 points here are optimistic effort, point 1, point 2, most likely effort, point 3, pessimist effort. Okay, so quite a simple estimation technique, but it will need a bit of understanding of the technical complexities, bit of understanding of the requirement, And then if you use this, definitely it can take you to close to your accurate efforts. Now let's move to the next one. And the last technique for discussion today, work breakdown structure estimation. This estimation technique is the most used technique in software world, not only in software, I think, in our day-to-day life as well, when we estimate something. For example, if we have a function in our home and we have to derive like, okay, what will the cost and what will be the budget and all, we usually unknowingly use work breakdown structure estimation technique. So what this technique says? This technique says that whatever requirement you have, break down to the granular level of details. If you look at the diagram here, you will see that it's kind of SDLC. You know, SDLC is software development lifecycle. What we do, we define the scope, analyze the requirement, we design high level and low level design for the development. Then we move into development phase where we do coding and unit testing. Then we move into testing, which is system integration testing, user acceptance testing and all. And once we have user acceptance testing sign off, we go for deployment. So these are the SDLC phases. In WBS, work breakdown structure, we identify the lowest level of work we are going to do in every phase. So if I'm into scope, identifying the scope, what will I do? I'll go to the client, I'll ask the requirement. Okay, boss, what you need? He will give me one-liner. Okay, boss, go and develop the system for me. Done. What is my next step? My next step is to elaborate that requirement from my understanding. Prepare a document, go back to the client and say, boss, this is what my understanding is about your requirement. And the client says, yeah, okay, it is 20% is correct. So 80% you didn't get me. Okay, good. Understand, listen, understand. This is my requirement. Again, I said, okay, fine. I'll go back to my document, correct that, prepare questionnaire along with the document. I'll go back to the client and say, boss, this is my document now. And these are my queries where I'm not very clear. Client says, okay, fine. Now you got 70% of it, 30% probably from your questionnaire. I'll answer that and you will get the 100% requirement. And this activity goes on until unless the client says that, yes, you got it right. Now go and develop. So you see, there are a lot of activities required in this, okay? Repetitive client interaction, repetitive document preparation, sign-offs and all. So the blocks you see here in the diagrams talks about those kind of activities. Similarly, when we go to analysis, we again drill down to the granular activity that we are going to do in this phase. And in design, similarly in development, testing, everything. Once we have that granular information, we start estimating from the leaf node. Leaf node means the most granular activity, the first thing that we are going to do. So taking the example of login screen again, what I need to have a database, first of all, a database designed. I need to have some tables in that where I can store my detail. I can store my user information. Then what I need a user interface where I'll have some text boxes where I will capture user ID, password, security question, OTPs, kind of things. In that user interface, I need certain validations. I need to see if the email ID is properly entered or not. I need to see if the password is aligned with the standards of password or not, like the correct number of characters, special characters, kind of things. I need to see if I'm properly capturing OTPs or not. I need to see if all the required fields are filled by the user or not. So many things, right? So these kind of details are captured and recorded into the plan. And then for each task, we start estimating. In WBS, we can combine both estimation approaches, sizing based and activity based. So what is the difference? The difference is in sizing based estimate, we again break down the functions in a granular level, but we give a weightage. We do not give efforts because we don't know what technology we are going to use to build a system. This is very important, guys. When should we go for size and when should we go for efforts? We should go for sizing when we do not have a clarity of the development environment, of the deployment environment. So we just say that, okay, boss, let me size it. And then I will derive my effort based on the technology I will decide. And how will I decide the technology? I will have a comparative analysis. Okay, what features are supported in what platform, in what language it will be quicker, and kind of things. So we go for a brainstorming session. So functional WBS is used when we have not decided what programming language I am going to use, what platform I am going to use. I give a size to my requirement and come up with the total size using work break structure. Activity based WBS, in that case, I know. So I'm going to use Java for this requirement. I'm going to use .NET for this requirement. This is my expertise. And for that particular requirement, the granular level task, I need these many days. Okay. And I will keep estimating the tasks. And at the end, I will roll up those tasks to the module and then to the project and give the total efforts required for it. So this is something called Gantt chart. I hope you guys would be familiar with it. Gantt chart, it is nothing but project management plan. So this is the screenshot you see is taken from the Microsoft project plan, MPP. The same can be designed into Excel as well. Many people do it in Excel, many people use MPP, right? So this is the project. So you see the phases, development phase, testing phase, deployment phase, so on. Hello? The voice is fine now or is still breaking? Oh, great. Thank you. So coming back to the point, in Gantt chart, we actually are defining the phases and then we are defining the tasks we are going to do in that phase. And then you see here the days. Okay. For each task, hello. Okay, maybe give me just 1 minute. Let me fix that. How is it now? Is it better? Okay, cool. Great. So anyhow, we are on the last slide of the presentation. So to understand in this slide is, we see the phases, we see the tasks, and we see the efforts, the timeline required to complete that task. And this also shows me from which day to which day I am going to complete this task based on the number of days I have given. So that's where we use the Microsoft project plan, which helped us to define the timelines. Okay, so this section, in this particular section, actually, what we do is the design phase takes 34.5 days, which is nothing but the total of the days we have given for each task. Similarly, based on this detail, we define the start and end date. And this gives me a chart. And this chart helped me to identify if I am overloaded, if I am underloaded, if I'm missing any duration, where which is the idle time for me. It also helps me to define the milestones for me. It again helps me to design my work in a parallel way. Means how many people can simultaneously work. We can also define the dependency. Okay. So with that, we conclude the work breakdown structure estimation. I hope the session is helpful for you guys, and it will be helpful in your day-to-day professional life as well. I'll move to the Q&A session. So if you have any questions, you can type that in the chat box and I can pick it from there and I'll answer that. Okay, guys, so summarize this. Yeah. So guys, you can type your questions into Q&A section and I can pick it from there. I'll try to answer your questions. So in summary, basically we had seen like what is estimation, why it's so important, what are the different types of estimation techniques, yeah, guys. So there is a question whether there are more techniques of estimation that you have that what you had explained. Yes, there are a lot of techniques actually. I have picked the one which are frequently used in IT industry. Okay, so mostly, as I said, like broadly, we pick it from size-based estimation or effort-based estimation. But there are different models. There are different execution models basically followed in IT industry, and based on the execution model, we pick the estimation technique which fits with that model. As I had explained, if we are working into agile mode, story point is the right estimation technique for you. Okay. If you have the granular details with you, go for the WBS. So guys, I would request you to use Q&A mode to answer. Okay, fine. So I have it there. Thank you. Okay, so I have a question from Arun. What is the best tool to create a Gantt chart? See, most of the organizations and most of the project managers use Microsoft Project Plan, MPP, to create the Gantt chart. It is the most used tool to create it. But there are other tools as well. They are less frequently used, but if you want to do some study, if you want to understand it, I would suggest you to just Google it out and just search for MPP, Microsoft Project Plan, and you can see the details over there, and you can see the task divisions that we discussed today. Hope I answered your question. Any other questions, guys? So we still have around 4-5 minutes. If you have any questions, we can pick that. We can discuss any topic that you could not understand today. Probably you can take that as well. Abhishek Kumar. Okay. Abhishek, I would request you to put your question into Q&A mode so that I can publish it and everyone can see that. Okay. So here's a question from Abhishek. In this formula, what does TDI means? So here TDI is total degree of influence. Yes, we discussed in function point estimation technique. And this was helping us to arrive on the adjusted function points. Okay. So again, another question from Abhishek. How we calculate TDI? Okay. So Abhishek, if you have noticed that we had one slide, let me share that slide again. If you remember this slide. So the right hand side, I had said that there are different categories that we define. These categories are of complexity, basically degree of influence. Okay, so we give a weightage based on the requirement implementation, and then that weightage is taken as a total degree of influence. And then we use the formula which I had given, and then we arrive on the total function point, adjusted function points. I think, I hope this slide is clear. These are some type of complexities that we define in our day-to-day estimation approaches. So we give weightage to it, and based on the weightage, we define the total degree of influence. Okay. Any other question? Okay, so I have a question. Okay, so let me publish that question. Is this weightage is flexible? Yes, that weightage is flexible, but sorry. If you go with the function point, there are defined weightages given by FPUG Institute, International Function Point User Group Institute. But if your requirement demands, you can change that figure, but you have to agree with your client on that weightage then. So usually we have our architects from client side as well. Whenever we propose something, basically we have to align with the technical team of the client, and we have to set the standards if we are changing anything in that. Okay. Any more questions, or we can wrap up today's session? So thank you all. You have been a nice audience. I hope the session would have helped you. And if you feel like we have to go in detail of any of the estimation technique, we can probably arrange some more sessions in future. And yeah, for the moment, I'll take the bid. Thank you so much, guys. We'll see you next time in future then. Thank you. Bye bye.